Recording. Okay. So this week, there's honestly not any like new content per se. Um, you guys on this quiz will likely just be doing just node voltage, mesh current, and maybe op amps, probably not op amps, and like a Thevenin equivalent, but all with impedances instead of resistances. So what that means is that, make sure you know how to do your complex number algebra. And what's nice though is that there's no like no new concepts. It's all the same stuff you've done before, just now everything is a complex number instead of a real resistance. So with that, like there's not really anything for me to go over per se. It's still the exact same procedure for node voltage. It's the exact same procedure for mesh current. It's the exact same procedure for Thevenin equivalent. It's just instead of resistances, you're using impedances. So I'm just gonna spend this time doing some example problems, which means this today's review session might be a bit shorter, but I'll just kind of get into it. One nice thing about the fact that complex number math is hard is that it's quite likely that you'll get a question where it'll just ask you to um, write out the equations and not actually have to solve it. So we're going to start with one of those. So this question is, in fact, one of these scenarios. So we just have a pretty complicated looking circuit. But by now, you guys hopefully have developed the tools to be able to solve these, regardless of how complicated they may seem. And I think that's everything here. Yeah, so you got 30 volts, uh, negative J4. Yeah, and it's quite likely like they might give it to you in time domain form, so they might give you like some number of farads, but as you guys should know by now, for a capacitor, it's negative J over omega C. For an inductor, CL, it's J omega L. But it's more than likely you're going to just be given the values directly in complex number form. So for this question, write all equations necessary to find VC. So VC, it's going to be actually VC bar because right now, since these are all complex numbers, we are in the frequency domain, which means that this 20 volts here is actually a 20 cosine omega t. But because we're in the frequency domain and it has no phase shift, we just write it as 20. So here, write all equations you would think are necessary, and use node voltage for this one. Make sure you read the question because it'll probably say whether they want you to use node voltage or if they want you to use mesh current. And the answer key that we're given is going to be grading based on, which one of those things you've been asked to do. So if we're going to do this like mesh current, or if we're going to do this like node voltage, sorry, we're just going to do the same way we always do. We decide one point is 0 volts, and then we find all of our nodes. So we have here is V1. This is also V1, as you can see, because they're connected right here. Um, the other essential nodes, so remember you put a node where more than two components meet. So this is not one. However, this is one. And I think that's it. We only have two nodes here. We have V1, it's properly V1 bar and V2 bar. So at V1 bar, we have that. So for V1, the way I always do this is just assume all currents are going out unless it like explicitly told otherwise by a current source. So we'd start with like I guess that doesn't really matter for these first two, but we can assume it's going that way and we're told it's going that way. Remember, currents going out are positive. So if we start writing the equation, right, we get 10 amps. I'm not going to write units. So 10, because this is positive 10 because it's going out. Plus, here we have V1 plus 20. minus V2. So if you want to think about this, right, the current going this way is the same as the current going through here. Right at this point, right, if we have V1 here, right here, it's going to be V1 plus 20. And then, but, and then we can find the current here. It's just going to be the voltage difference, which is V1 plus 20 minus V2 over that J6. And then, so that's up. We've done up and down. And then we also have to do up and down out here because that's also in the same node. Uh, so we just, for going up, we have V1 minus V2 over 9 plus, and then again, we have V1 minus 0 over, oh, I forgot. Oh, no, I didn't. Yeah, over negative J10 equals 0. Make sure you put that equals 0 or else you will get points taken off. V2, very similar. We got I'll go left and then down and then right. So going left, we have V2 minus V1 plus 20 for the same reasons I said earlier over J6 plus V2 minus V1 over 9 plus V2 minus 30 because if this is 0, then this would be 30. So minus 30 over negative J4 equals 0. By the way, if anyone has any questions throughout the course of this, ask in the chat. I'll look over every so often and hopefully I see your question. And then one key thing though, again, this is read the question. Make sure you always read the question at the beginning of doing the quizzes because you might miss something. So here we want to find all necessary equations to find VC. So in this case, what is VC? VC, quite simply, if we look at it, would just be the difference between this point and this point, right? This point is V2, this point is 30 volts, so VC would be V2 minus 30. So these three equations together would make up your answer for this kind of quiz question. Again, very straightforward. It's nothing you haven't seen before. It's just with different numbers, but it's really the exact same thing. It shouldn't be that bad. What could be a bit harder though is you could be asked about Thevenin equivalence. So this question here, it's kind of tricky looking, but in reality, it's not that bad. So give me a second to draw it here. And so here, the question is determine the Thevenin equivalent with respect to B and C. So I hear this question, I think, okay, B and C, that means that this A branch does not matter. So straight off the bat, we can redraw the circuit and just destroy the A branch because it doesn't matter. This could happen on a quiz, they just give you extraneous information to make sure you understand what you're doing. So here, right, it's asking for B and C, so we do not care about A at all. There's also not going to be any current flowing through A because it just ends. So on and so forth, doesn't matter. So the other thing is that we're going to say that VBC equals V Thevenin because it's with respect to B and C. So from here, oh, I didn't actually write down what this is. This is 4 ohms. So from here, we do the normal thing. We look at what the voltage is across B and C, which would be the same thing as the voltage across here because they're connected directly. So for that, this is just really a normal voltage division because we have one resistor here. Switch to the lead one. We have one resistor, one resistor, one resistor. There's only one loop that current can flow through. So the voltage across that 4 ohm resistor is going to be basically just a simple voltage division. Another thing, if you see it written, a voltage written in this form, that's just another way of writing 24 e to the j0 degrees. That would be equivalent be with that angle. So like if you had a 30-degree phase shift, it could be like 24 angle 30 degrees. That would be the same as 24 e to the j30. It's just a different way to write it that makes it more like intuitive and less mathematical, I guess. So just don't get scared if you see that on your exam or on your quiz. So yeah, so we want to find VTH is simply going to be that 24 volts times, and then our voltage divider, 4 ohms over 4 plus J6 plus 4. And if we add these up, we get 24. So here on this kind of question, you would actually have to do the math. I know recently the policy changed that you now have to like actually show your work, which makes sense, honestly. You can't just put it in your calculator. Of course, you can still use your calculator to check your work, and I would recommend using your calculator to check your work, but you have to show that you would know how to do it without a calculator as well. So here we have 24 times 4 over 8 plus J6. So what we do then is when you're doing division, we have to convert this to a phasor. So 8 plus J6, um, there you can get, right? We need to turn A plus BI or A plus BJ into our A to the E J theta form. So can do this in any of the ways he taught you. So we start, if we want to find theta, theta equals the negative tangent of the imaginary part, so 6 over 8. If I plug that into a calculator, I would get 36.87 degrees. And then A is going to be that real part divided by the cosine of the angle. So cosine of 36.87 degrees, which would get you about 10. Personally, I use a different formula for A because I can remember it better. Because if you think about your complex number like lying in the complex plane, right? If you got your real and imaginary part and you're at 8 plus 6A, right? This is the magnitude is the length of this line. So you can just like do the distance formula. So I would just do 8 squared plus 6 squared, and you would also get 10, I think. Let's see. Let me make sure of that. 8 squared plus 6 squared. Yeah, you get 10. So use either of these formulas. It doesn't really matter. You'll get the same number. It's all trig. So anyway, what we get here is after doing this, shift it over a little bit, right? This is 24 times 4e to the j0 over 10 e to the j 36.87, which when you do that, right, you get 24 times 4 tenths e to the negative j 36.87. If you then do 24 times 4 divided by 10, you get 9.6. So your VTH finally would be 9.6 e to the negative j 36.87. If I were to plug this expression into my calculator, I would get the exact same thing. However, you guys got to show your work now. So show your work. Um, Likewise, we do the same procedure you're familiar with to find the equivalent impedance instead of the equivalent resistance. So we would short this, right? We short when you're doing it, you can either do it with like the I short circuit where you do this and find the current going through here, or if there's no dependent sources, it is much easier to neutralize the sources. So here we neutralize that voltage source by converting it into a wire. A wire has 0 volts across it, so that's like the opposite of having a voltage source. And then you would find the equivalent resistance between B and C. So here, right, I'll redraw the circuit a little bit. So we have B and we have C. And then if you were to redraw this circuit, right, it's like kind of like that, right? So I've seen people on quizzes like making a mistake and just kind of adding together all 3 of the resistances. you can't do that because if you think about it from the perspective of B and C, right, there's two paths you can go through. You can either go that way or you can go that way. So really, this path is in parallel with this path, which is a bit more clear when you redraw it like this. So what you actually have to do is that you'd have some Z equivalent would be your 4 ohm branch in parallel. This is a symbol for just like in parallel with that 4 plus J6. So here, uh, again, this is something you really want to check with your calculator because it's very easy to mess this stuff up. Um, so this would be 4 times, so okay, I'll write it as, yeah, it's 4 times 4 plus J6 over 4 plus J6. The same way that like R1 in parallel with R2 was R1, R2 over R1 plus R2. We're doing the same thing, just it's with complex numbers now instead. Again, everything in this unit is the exact same thing. You just have complex numbers now. So here, we do it on top. We get, what's that, like 16 plus 24J over 8 plus 6J. And then we have to can either turn these both into phasors and then like divide, or you could actually no, you don't want to turn it into phasors because for resistances you leave it in a plus bi mode. So what you do then is multiply by the conjugate. So 8 over 6 minus 6j, 8 minus 6j. This will just make the imaginary part in the denominator cancel, and then you'll get a nicer looking number. So here, right, you got 8 times 16 is, I need a calculator for this. 8 times 16 is 128. Plus 16 times negative 6 is 96. I need to minus 96j. 8 times 24 is 192. And then 24 times 6 is 144. And for this one, be careful with the sign because it's a positive times a negative, so it would be a negative, but then you'd have j squared, which is another negative. So this would be a positive. And then on the denominator, I think there's like a formula you learn for this. If I'm writing this up top, you have a plus bi times a minus bi. The term in the middle is going to cancel, and you'll end up with a squared minus b squared. I meant to write, or a squared plus b squared, sorry. Yeah. Um, it's like the difference of squares formula, but then there's like a I squared in it, so it becomes a plus. So we got, yeah, 8 squared is 64 plus 36. If you then simplify this a bit more, you get 128 plus 144 is 272 plus J96. That's going to be that 190. Wait, I think, yeah, 192 minus 96 is actually just 96. Yep, over 100. And then this easily just becomes 2.72 plus J 0.96, right? And this would be your final Z equivalent. Because remember, what we did is we're saying, okay, what's the resistance between B and C? And the resistance between B and C is this in parallel with this. And that's what this initial equation we made was. It's like this. And then we did all the math, and we get this as our final answer. So then I'm kind of out of space on the page here. I'll move this up a little bit. So then our final answer, right, would be writing a Thevenin equivalent circuit. So we got our plus minus, we got our impedance box, and we'd write it as, let's see, our Thevenin equivalent voltage. I'll put some boxes around this in case people are, oh, make sure you put the degrees in unit. I forgot that. You don't want to forget that. There you go. And, okay. Beautiful. So again, we'd have 9.6 e to the j 38 point. How did that line just show up? The hell? Is that real? Yes. Okay, whatever. E to the minus 36.87 degrees volts. And likewise, we just put in that 2.72 plus J 0.96 ohms. And that would be our final answer. So on this kind of question, make sure you draw your final circuit because that is ultimately what your answer is. And if you want to be really fancy, this is B, this is C, because that's what the initial question was. It was with respect to B and C. So again, if you get a question like this, it's just the same way you've always done Thevenin equivalence. It's just now you have complex numbers. It's all just the same thing with complex numbers. There's nothing new. Okay, I have a few more questions I could do, but honestly, there's not too much stuff to go over. Um, let's see what could be interesting. Here's one with mesh current where you just write the equations. So we got something that looks a little bit like this. And then we got hmm. Okay, so this one, it's actually written in the time domain, so you will have to do a bit of conversion at the beginning. This will be good practice. So you got 0.5 millifarads, and we got V of t, and we're given that V of t equals 15 cosine 1000 t plus 45 degrees. So to start, oh, and the question is, right? Oh, and important, this is Ix. So write all equations to solve the circuit. So this is just everything you would need to find like any value. So this is just going to be the three mesh equations and your dependent source equation. So, but here, just we don't want to ever think about doing this in the time domain. That would be way too many differential equations. So of course, we are starting by converting this to the frequency domain. So our omega equals 1000. We got that from here, right? And so we'd want to figure out what all those equivalent impedances are. And by all of those, I mean like all three of them. So for that first inductor, I'll say Z1, this can be Z1, this can be Z2, this can be Z3, right? Our Z1 is going to be J times 1000 times 2 times 10 to the negative 3, which is, if you take this one and this one, they'll cancel. So you'll just get 2J. Z2, likewise, by the same math, would be 4J. Hopefully that's pretty clear. And Z3 would be negative J over 1000 times 0.5 times 10 to the negative 3, which would be negative J over 0.5, which would be negative 2J. So that's going to be your three things. So if we redraw the circuit, oh, and this VT would go to 15 e to the j 45 degrees, just because it has that 45 there as its phase shift. So now, if we redraw the circuit, I'll just copy and paste it because that'll be easier. We redraw the circuit. We got that's not what I tried to copy. Probably would have just been faster to draw it at this point, but come on, there we go. Okay, so if we redraw this, And the dependent source doesn't change because it'll still like take the, but now it'll be like the complex current, I guess, instead of the real current. But that it'll still be two times the current. So now instead of that four and this and that, I don't know why I said it like that. But now we have Z1 equals 2J, Z2 equals 4J, and Z3 equals negative 2J. And now the rest of the question is pretty straightforward. It's just normal mesh current. And hopefully we all know how to do this by now. So let me write this out here. We got our 15e to the j 45 degrees. We define our mesh currents. I always define them going clockwise. It really doesn't matter. It's like I bar one, I bar two, I bar three. That's the notation you like technically should be using. It really doesn't matter. But we got our I bar one equation, and it's going to be just going around that loop. So going around this loop, this raises the voltage, so we write it as negative. So we got minus 15e to the j 45 degrees plus I1, or I'll write it in the other order, plus 5I1 plus, I'll put this in parentheses to make it just a bit clear, minus I2j I1, I1 minus I2, right? Equals 0. That's our first equation. I2, I'll start with that minus 2j again. So we got minus 2j times I2 minus I1. If you really want to be annoying, you could like put every single bar on here. I don't think anyone cares if you do that though. But technically that is more correct. Uh, and then with the inductor, we'd have plus 2j times just I2. And then with that resistor, we'd have plus 2, it's just 2 here because it's a resistor, plus 2 times I2 minus I3. And then that dependent source is just going to be plus 2, I'll just keep calling it IX, or I'll call it I bar X to be proper. So plus 2 I bar X. Okay, moving on then. And that equals 0. Always make sure you have the equal 0. And then I3, we will have, again, it's the same thing you've always done. I'll start with this one this time, so I'll start with the 2ix. Now it's going to be a minus 2ix because we're going in the other direction. So minus 2ix, and then the 2 ohm resistor, so plus 2 times I3 minus I2. And then the other two are just with the, oh, this is not a 5, I don't think. I think that was supposed to be, yeah, it's supposed to be a 6 ohms. Doesn't matter. I just wrote the question wrong. 6 ohms. You would get a different answer if you were actually writing it out, but again, with this kind of quiz question, you wouldn't actually be writing it out. So it doesn't matter that I messed this up. 6 I3 minus I2. Or no, this is just I3. My bad. Because this is just alone on the path there, right? With the I2, we have this one going this direction, this one going in this direction. That's why we do the subtraction. But here it is just the I3 going through it. So 6I3 plus 4J I3 equals 0. And you might think you're done here, you've done all of them, but make sure you put that dependent source equation because right now we have 4 variables and 3 equations because this is still a variable. So we simply just have to write that Ix equals I2. And then we're done because it's going in the same direction here. And this would be your answer for this kind of equation. And you don't have to do any conversion like back to the time domain. This kind of question would just be making sure that you know how to convert your values to the frequency domain or how to convert your like capacitances and inductances to impedances, and then making sure you know how to do mesh current. And then what else can I do? there's not really much else to cover, honestly. Like it's all very much just stuff you have already done, but with a different packaging. Um, I'll do just because we have so much time, I'll do one more kind of easy Thevenin equivalent, and then I'll do an op amp question. I don't think you'll have an op amp question, but it could always happen. Um, so here's another Thevenin equivalent. I don't want to be in blue. Find Thevenin equivalent with respect to A and B. And this one is kind of as straightforward as your Thevenin equivalent questions could get. It's very similar to the previous one we did just now. It's not even like trying to trick you with the extra stuff. So we got J60, 36, and negative J48. We got A and we got B. So to start, we find in the Thevenin equivalent voltage. And that's, again, just going to be a voltage divider. So we got 24 times 36 over 36 plus J60 minus J48. If we do 60 minus 48, we get 12. So we have 24 times 36 over 36 plus 12J. You can, I guess, divide the top and bottom by 36 if you want. Yeah, sure. Um, Actually, it really doesn't matter because we have to convert the bottom to phasor anyway. It's fine. So yeah, we got theta equals tangent inverse. We have to convert it to phasor because we want a voltage at the output, and the voltage is written in a phasor form. So on the bottom here, we got negative. The theta is going to be negative tangent or tangent inverse of 12 over 36, which gives us let's see, second tan 12 over 36 in degrees. That would give us 18.43 degrees. And then our magnitude is the real component, so 36 over cosine of 18.43 degrees. So 36 over cosine of that gets us 37.95. So then we have does that seem right? We should also be 36 squared plus 12 squared to the power of 0.5. Yeah, okay. So we're here. So then we have that it's 24 times 36 over 37.95 e to the j 18.43 degrees. And this can be thought of as e to the j 0 degrees. So what we do then is we subtract the phase and we multiply and divide everything else like it's a constant. So if I do in my calculator 24 times 36 times that 37 number, um, oh, not times. That's have to be divided by that last number, right? We get, did I mess something up somewhere? I don't think so. Um, oh, no, yeah, I'm doing fine. Okay, so we get 22.77 e to the negative j 18.43 degrees. And that would be our Thevenin equivalent voltage. Again, it's the exact same way we did it before. It's just with complex numbers. And then for that ZTH we're looking for, it's the same thing as last time, right? We neutralize the source. So we pretend that's a wire. And then we say, okay, there's one path that the current could go there, and there's another path that could go there. So we take this in parallel with these two. So we got 36 in parallel with negative, we did this math earlier, that's going to be 12J when they're added together. So that's the J60 minus J48 over 36 plus 12J. So here, again, we do the same thing we did with the last question where, because we want to get it in complex number mode, we do 36 minus 12J over 36 minus 12J. This is multiplying by the conjugate to make the denominator real. So when you do that, 36 times 12 is, I'm just gonna do the math here. It's like the same stuff you did before. Actually, it's gonna be a lot easier if before we do all this, we just divide everything by 12. So this is gonna be 3 times 1J over 3 plus J, which is just 3J over 3 plus J, right? Yeah, let me make sure I'm doing this right. 12 times 36. Yeah. Minus. Oh, I made a bit of an error here. This does not become 3. This stays as 36 because if you're dividing by 12, only one of these, since they're multiplied together, only one of them would get kind of canceled. So this would become 36J over 3 plus J. And then we multiply by 3 minus J over 3 minus J. This is the kind of thing that's very easy to mess up here because when it's on the bot, when they're added together, you like divide each of them separately, but when they're multiplied together, you can only divide one of them out. That's just an algebra thing. So then here we have 36 times 3 is 72. 72J, and then this would be J times J, but it's negative, so you'll get plus 36. I think I did that right. No, it's 36 times 3 is not 72. That was just silly of me. 36 times 3 is 108J. And then on the bottom, it's 3 squared plus 1 squared. So 3 squared is 9 plus 1. So then we get 100 or 36 plus 108J over 10. And so then our final ZTH would be 3.6 plus 10.8 J ohms. And that would look, and then if we, again, you always got to redraw that final circuit, it would look something like this, where you got 3.6 plus 110, 10.8 J ohms. And from before, we had that 22.77 e to the negative J 18.43 degrees volts. And that would be your final answer. So what I was saying earlier though about how you can like check your work with the calculator even though you still have to show all your work. With this expression, for example, I can just go into my calculator and plug in the whole thing and I do 36 times 12 I over 36 plus 12 I. And sure enough, I get the exact same thing. So that just tells me that I did it right. You still have to show all your work on the exam, but it's a nice thing that you can just check to make sure you did your work right. Okay, last but not least, I'm gonna do a what's it called? Op-amp question. I have no idea if you'll have an op-amp question, but I think they've had them in the past, so it could happen. I think you had one on your homework. So got 5 sine 1000t, which I'm gonna do the quick work of immediately converting this minus 90 degrees. Okay, and then I'll redraw the rest of the circuit. Okay, so we got 10K and 0.1 microfarads. So first thing we have to do, convert your capacitances to impedances. So we'd have negative J over 1000 times 0.1 times 10 to the negative 6. If I plug that into my calculator, because I think that'll probably be like 10,000, 10K or something like that. But if I do negative I over 1,000 times 0.1 times 10 to the negative 6, yeah, sure enough, I get that's negative J 10 kilo ohms. So yeah, and then again, and this would just be 5 e to the negative J 90 degrees. Um, So the way you do this, again, it's the exact same way you did op amps in the past. So with your ideal op amp model, remember your Vn is equal to your Vp. In this case, your Vp equals 0, so therefore your Vn equals 0. And then you do just kind of like a node voltage about your Vn. So we'd say at Vn, we got Vn minus 5e to the j90 over 1k plus Vn minus V out over negative J 10K plus Vn minus V out over a normal 10K equals 0. If we multiply everything by 10K, I guess we'll do that, sure. Yeah, then we get 10 Vn minus 50 e to the negative e to the j90. This is supposed to be negative. Um, and then plus Vn minus V out plus Vn minus V out equals 0. We want to find V out. So, oh yeah, I should have written that. Find V out of t. So V out here, right? We move our V outs to the other side. We'll have 2 V out equals 12 Vn minus 50 e to the negative j90. And if you remember from earlier, uh, Vn is 0. So, oh wait, it's not actually that simple. I messed up something. My bad. Because this has a j in the bottom. Okay. So let me backtrack a bit. I thought this was being a bit too easy. So, one good thing to remember is that 1 over j equals negative j. And likewise, 1 over negative j equals j. So here, when you have j on the bottom, right, this can become jvn plus jv out plus vn minus, or minus v out equals 0. Okay, so then what you have, right, is your vn's all don't exist because vn is 0. So what we really have is minus 50 e to the negative j90 um, minus jv out minus v out equals 0. If you rearrange things a bit, you get v out times 1 plus j equals negative 50 e to the negative j90. And then you divide, v out equals negative 50 e negative j90 over 1 plus j. If you want to convert this to phasor, right, it would be theta equals tangent inverse of 1 over 1, which is 45 degrees. And then the magnitude would be 1 over cosine 45, which gets you just root 2. Another way you can really convert this one in your head because like it's it's at 1 in 1, right? That's your phasor with the real and imaginary component. And so the angle has to be 45 degrees because it's like up 1 over 1. And then just the diagonal of a 1 by 1 square is root 2. Maybe you know that. Anyway, but you can always just do that formula. If it were me, I would probably just go directly to the endpoint because I'm thinking about the imaginary numbers in terms of the plane. But anyway, then we get V out equals negative 50 e to the negative j90 over root 2 e to the j45. And if you do that, you get negative 50 over root 2, which is negative 50 over the square root of 2 is negative 35. What's a 3? Negative 35 over 3 over negative 35.36-ish e to the negative j 135 degrees. Um, One thing about phasors though is if you remember, we always want to have our phasors be positive. Um, that's just the convention. And so if you remember though, a e to the j, I don't know, I'll say j theta, equals or negative ae to the j theta equals ae to the j theta plus 180. That's because if you have a sine wave and you shift it by 180 degrees, that's like half its phase. So then it would become the negative version. So it works. So this is the thing. So here, if we do 135, and I'm going to do it's either plus or minus 90. Here we have a negative 135, so I'm going to plus 180. And then we get negative 45 degrees, or we'd get a positive 45 degrees, sorry. So we could say this equals 35.36 e to the j 45 degrees, because negative 135 plus 180 equals 45. And then finally, if we want to get v out of t, we just convert this v out phasor back into a real number, or into a real function. So that would be v out of t equals that magnitude 35.36 times cosine of our omega, if we remember back here, was 1,000. So 1,000 t and then plus 45 degrees. And that would be our final answer. Yeah. So, you know, it's like everything in this unit is the same thing, but now you're using complex numbers. That's really all there is to say about it. So make sure you're good at your complex math and don't like make sad mistakes. Um, yeah, that's about it. Does anyone have any questions? I'll wait like 10 seconds for someone to unmute or type something. Okay, then in that case, I'll stop the recording.